right. What it asked you. Yeah. All right. Let's hope and let this be. And if you want me to put these in your in your black folder, I can. If you want to keep them, you can. It doesn't matter to me. Um, this, of course, was the 2015 test, so we're getting closer and closer to 2021. I don't think they said they're not going to release the 2021 test for whatever reason. In 2020, I wouldn't bank on because that was COVID year. It was there. But we're getting more and more recent. Okay, so the first one. Calculator is required, and when they do that, y'all please let your calculator do the work for you. This one was a little difficult in my opinion because of the two equations in there. The rate at which rainwater flows into a drain pipe. I read through it completely one time, then I went back through when I saw the two equations, read through it again and highlighted so I could kind of get everything into my brain. So it's coming into the pipeline at a rate, and what does that tell me already? It's a derivative. Exactly right. Into 20, when I write these things up here, I'm telling y'all, I note these on my paper as well. I will mark up a problem as I'm reading through it to make sure I understand what it is that's going on. All right, in cubic feet per hour, T is measured in hours. I'm between 0 and 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate. So out at a rate. So again, I'm talking about another derivative. D of T equals negative 0.04 T cubed plus 0.4 T squared plus 0.96 T. I went ahead and took out my calculator because I knew this was graphing calculator, and of course I'm going to have to continually reference these equations. I went ahead and put this one in Y1 and this one in Y2, not even knowing what I'm going to do with them. I'm going to put them in there so I can keep referencing them. Just trying to give you some little tips here to help you with some time-saving things. You can always reference those back out. All right, there's 30 cubic feet of water in the pipe at time T0. That is always important. My initial amount was 30. I haven't done anything yet, but I got a feel for the problem. I got a pipe, water's coming in, water's going out. There was already some water in there when the time started. Everybody good? Yes, Miss Marie, we're good. Good. Okay, how many cubic feet of rainwater flow into the pipe during the 8-hour interval? So which equation do I need to use? R of T. So the only thing you're doing for part A is the integral from 0 to 8 of R of T dt. Put the dt, but you don't have to write, I wrote out 20 sine T squared over 35. You don't even have to do that. It's already been defined in the problem. Save yourself some time and just write R of T dt. Be done with it. You got a point for the integrand. And then you got a point for giving the correct answer. This is straight on your calculator, guys. That's what I did, yes. So I did, but if you didn't, it's okay. Don't forget the DT. I'm not 100% sure if they take, at one point they were taking a point off for that. They weren't giving you your answer point if you didn't have it, but always put the DT on there. Ooh, I forgot my DT on here. And then the answer was 76.570 cubic feet. Can everyone get that on your calculator? Sure. Okay. 2-point question, one for the integram, one for the answer. Yeah. Please remember, please remember. Okay. Go ahead.
I thought that we could add the initial question.
Well, it didn't, and that was the thing. And I actually made a note in here because that was my initial thought too. Don't forget to add that 30 in there. But it says it doesn't say how many feet are in the pipe. It says how many cubic feet flow into the pipe during that 8 hours. So now if it had said how many total cubic feet are in the pipe after 8 hours, then you would add that initial amount. I feel like they word these a little bit differently every time just to make sure you understand what it is. Do I add the initial amount and do I not? All right, part B. That was good to think about that though. Is the amount of water in the pipe increasing or decreasing at time t equals 3? Give a reason for your answer. What y'all say? Why? You have to give a reason. You did the rate it both. So you found R of 3. R of 3, I did the same. R of 3 was 5.086 cubic feet per, is it minute or hour? Hour. And D of 3 was, I got 6 point. Did y'all? Okay, I must have done it wrong. 5 point what? And so if you subtract them, right? Oh, I know I didn't do that one wrong. That's exactly right. Is when you subtract, if you do the amount coming in minus the amount going out, it's going to be the amount in minus out. So R minus B. Yeah, wait, it's really don't work. So on part A, I don't know why I think the audio was part A. Whatever that comes out to be. I wrote, it is, okay. Okay. I wrote that it's flowing out faster than in, therefore the water is decreasing at T equals 3 hours. All right, so let's look at the scoring guide. Yeah. I would say yes. Okay, so it's 2 points. If you considered R of 3 and D of 3, so somewhere on there you have R of 3 and D of 3, you get a point. You knew to use the derivative equation given. And then if your answer with your reason. At some point if you said it's flowing out faster, it's flowing in because that, whichever way you said it, you considered those values, then you get a point there. So that one was 2 points. Yeah. Remember, this is calculator, so work is at a minimum on these two. Correct. So it's flowing out faster than it's flowing in. All right, and then the good one. I did way more work on this one than what I had to, and I realized that once I got through it. But for which one? For C. 3.272. Okay, well, not the intersection. Okay, so let me show you what you had to do, because here's what you have to consider, though. Here's what you have to consider. All right, so part C asks, when is the amount of water in the pipe at a minimum?
So what should you think?
It has to equal the same. When I see minimum, they have to equal each other. The very first thing I did was this, and I started a sign chart.
Okay, but what values?
So what values do we need? Yeah. So I said that R of T doesn't equal D of T. At that time. Oh, at that time. Is that what I'm supposed to do? I didn't know what to do. When R of T equals D of T, the water's not a minimum, there is no water.
Wait, so what's the answer?
Okay, so the answer is 3.27. Let me explain it this way, and then let me go back to that, because technically you did it, but it's not the right. Let me explain. Okay, so how much water is in the pipe? What's your total amount of water? Your total, but in terms of at any particular time, or at the end of 8 minutes, right? At the end of 8 minutes, you have to go from 0 to 8. You take the amount coming in, which is your R, and you have to subtract out the amount that's flowing out, plus that initial amount of 30. That's the way I started this problem. So then that's the same thing as 0 to 8 of, and I can combine these here, minus D of. Okay. So my question is, when is this at a minimum, right? And these are already derivative equations. Are y'all following me? So what I did was I said, well, when does R of t minus d of t equal 0? Because that's the derivative. This is the derivative. When does the derivative equal 0? Between 0 and 8. Then it does equal. That's what I was saying. I'd have to think about that to see. Because on the scoring guide, it literally says you get a point for considering this.
So, but would it be RT?
But technically that is R of t equals d of t. But are you considering it because you understand that at 0, that's where sign changes happen? In other words, this, you got 3.272. It was negative and positive, so therefore, at time t equals 3.272, it's at a minimum.
That's like what I said, but I didn't do, like, I just.
Yeah, I didn't do that.
That, at 3.27, that's where it stops.
Okay, so let me tell you, this is how I feel like mine flows with that. They did theirs a little bit differently. I did a sign chart and I said at time 3.272 hours. The water is at a minimum because the sign of R of t minus d of t changes from negative to positive at this time. They said, yeah.
How do you know that middle number? How do you know the number?
So I graphed R of t minus d of t. Remember, in the very beginning, I set up in my, wherever it was, my y1 and y2, and that way I could just put on those y1 and y2.
So you're just graphing it?
Well, so what I did was I hit y equals, okay, and y1 and y2 are already there. So in y3, I put y1 minus y2. I cut off the graphs for 1 and 2. All right, so you got 1 point for considering. I'm going to let y'all be the judge on if you give yourself a point on this or not, okay? Y'all decide. I'm just going to read you the scoring guide, and y'all self-evaluate. Okay. Considers R of t minus d of t equals 0, that's 1. 1 point for the answer, which was 3.271, or 3.272. Make sure you're going out 3 decimal points. And 1 for the justification. Their justification was showing the intersection. They did a chart. I did a sign analysis. And then they said the amount of water in the pipe is a minimum at time blah. I don't think their justification is as good as my justification. Their justification is that they did a T-chart. At 0, there was 30. At 3.2, there was 27. And at 8, there was 48. So therefore, it was at a minimum at that point because it's better.
So, it stops decreasing the stress.
All right. The last one was the easiest one because it said the pipe can hold 50 cubic feet of water before overflowing. When T is bigger than 8, the water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving. All right. Anybody get it? And then what? You're amazingly close on that one. So I didn't divide up 0 to 8. I just did 0 to W.
Wait, that's the same thing.
But yes, the same thing, but you forgot one thing. Plus 30. That's exactly right.
I wrote it out the RQ.
From 0, so if you did 0 to 8 and then 8 to W and you added those two integrals together, I would definitely think that that's worthy of credit. You got 1 point for the integral, 1 point for the equation.
I just did two separate integrals.
Mm-hmm.
And I wrote it all out.
That's fine. So you did from 0 to 8 plus from 8 to W? Is that what you're saying? Did you do the plus 30? Put it to 50, then you got 5 points. Because if it overflows at 50, well, when does it hit 50? That's when it overflows.
What do you have to include? Yeah, I knew that because I like bend it in somewhere.
Huh?
What do you have to include?
Because if you want to know how much water's in the tank, you have to consider how much was in it to start with. It had 30 to start with. At some point, when they give you that initial condition, you're going to use it somewhere, somehow, in one of those problems.
So if you just split it out, you use it twice. RC back.
Yeah. All right. That was exactly 15 minutes. Now let's do that same thing for number 2. Let f and g be the functions defined by. Again, when I got to this one, I always label my graphs and everything else as I go through.
I subtracted the little areas and I added the areas together.
Right.
Yes, I got 1.9. I got 2.2.
That's what I got. Let's go.
I always write the whole thing out. Just didn't add your final decimal. I made sure it's small.
Again, whenever I started this, I had the least amount of work for this one. Well, as I started this one, I did go ahead and plug in my calculator, and I let f of x be y1, I let g of x be y2, so I didn't have to keep, and I literally labeled that everywhere so I wouldn't forget. I went ahead and found the intersection point because I knew that was going to be, as soon as I looked at this problem, I went, yep, this is going to be rotation, it's going to be volume and area. I'm going to need that intersection point. They were nice enough to give me the 2 on the ends. I just found the 1 in the middle. So that's all you see here. That's what I found on my calculator. And the first was to find the sum of the areas of R and S. This is just top curve minus bottom curve. That's all it is. And so the area is the integral from.
It wasn't working. My computer was not.
I defined that middle point as A.
That is fine. If you said the point AB equals, and then you said this point, then you could refer back to that being H.
Oh, I said A.
Yeah, that's fine. That's fine. Make sure it's down in the problem where they read, not just up at the top. If you want it scored, yeah. All right. This is, oh, and then you have to add to that from 1.0328. I tend to write everything just because I'm so paranoid that I'm going to get a reader that's going to say, nope, not today. All right, f of x minus g of x. I usually don't even write it. I did this time because I wanted to save a little bit of time, but yeah, remember the dx's. But it is enough just to do that. If I remember that my g is y2 and my f is y1, this was strictly calculator. There was not a lot more work that I needed to do for it. I did come out and show that this was 0.99 7426658. I'd never ever round on these until the very last step.
Yeah, because that 5.8.
I would just like to say there's definitely a calculator error on my part. Because I did everything right, and my calculator would not calculate. The 7, the 1,
I was so surprised to see how heavily weighted this one question was because I thought it was easy. This one, part A was 4 points. One point for the limits, 2 points for the integrands, and 1 point for the answer. You got 3 out of the 4, even if your answer was wrong. So I was surprised. I thought that was a very heavily weighted, like that was significant. That's like a differential equation weight on that one. Okay, let's keep going. Part B. 1.283. All right, I will not lie. I read part B wrong and I did way more than what I had to. And I went back and I was like, I would have lost credit on that because I didn't read. Part B was 3 points. All right, Region S. I did not read Region S. And that's a fault that I fuss at y'all all the time. Read carefully. It says, I just assumed I was finding the volume of everything, but it's not. It's just Region S. So, the volume of S, remember I'm talking about squares perpendicular, so I just need the side length of the square. The side length of the square is top curve minus bottom curve, right? So that would be G minus F, no, F minus G, I'm sorry. F minus G, that's the side length. I square it for the area, right? And I'm going to do that from that intersection point, which is 1.0328319 to 2 dx.
Okay, so
Is that a point? Is that a, wait, okay, so.
2 for the integram, 1 for the answer.
Okay, so what happened right here? Was it that I squared both of them? I did top
Yes,
minus
it's
bottom.
this minus this and then squared, not this squared minus this squared.
Okay, so how many points is it? So how many points is this out of 3?
I would probably set. Well, I'm probably gonna say 0 because you get 2 for the integrand and then 1 for the answer.
So did I get the integrand right though? Or does the
Well, you
integrand
got the
include
bounds
this whole
right.
thing?
Yes, it includes all that. Good. Part C. H is the vertical distance between the graphs. Okay, so I read through this one first and I went, this is really weird. But then whenever you thought about it, yeah. So the vertical distance, H, would be f of x minus g of x. That's how far apart the two are. This is C, yeah. So then it said to find the rate at which 8 changes. Rate means derivative. So I knew I'm finding a derivative at 1.8. So this is what I need to find. So the derivative of h, well, I can split up derivatives as long as I'm adding and subtracting, right? So this is f prime of x minus g prime of x. So h prime of 1.8 is going to be the derivative of f at 1.8 minus the derivative of g at 1.8. I used my calculator on n-deriv. I've still got y1 and y2 plugged in. This came out to be like 2.116283714 something minus 5.928000. I told y'all I only round at the end. I'm super paranoid. 72. Negative 3.811. 1 point for considering h prime. You considered the derivative of h prime. Somewhere around here you have this written. Or just this. And 1 for the answer. So 2 points. Are you seeing an improvement in your scores? Yay! Okay. Are you starting to see the pattern in the FRQs? Oh my gosh. There are several that you just have to master. I'm going to knock y'all upside your head if you don't master the Riemann sums. Finish that one 5 minutes early. All right. Johanna jogs along a straight path for 40 minutes. Johanna's velocity, so be careful, you know that's velocity, it's not position, is in the table, measured in meters per minute. Use the data in the table to estimate the derivative at 16. If I want to estimate the derivative, I'm going to need to do AROC because it's a table, right? So the 2 between 16 would be V of 12 and V of 20. Those were the closest ones. So I said the derivative at 16 is approximately 240 minus 200 over 20 minus 12, which is approximately, remember you don't have a calculator, I had 40 over 8, which is 5 meters per minute. That was 1 point. One great big point just for getting 5. Part B, using correct units, explain the meaning of the definite integral. That's exactly what it is. Okay, but you have to. Okay. Yay! Sorry, I was thinking. This is the total distance Johanna jogs in meters over the interval 0 to 40 minutes. I put total distance traveled in meters during the first 40 minutes. I did not put Johanna's name, but apparently they want Johanna. I don't know. 1 point, 1 point for the 1 point for the explanation. Then it said approximate using a right Riemann sum.
But I get a point, so I said it. I said it like we got to say
7,600.
I said it's the total amount of meters traveled.
How many points is 7,000?
Yes.
How many points?
1 point for the right Riemann sum, 1 point for the approximation. So this was 3 points. 7,600. All right, so let's do it. So this one I thought was a lot of computation without a calculator. You did, and it was awful. I was off to the side, like adding like I was in 2nd grade and multiplying like I was in 3rd. It was ridiculous. Okay, 0, 200. I just want to write these up here so I can show you. 220 and 150. Now you do have to remember the velocity has to be positive, right? So anything that's negative, I'm going to change to positive because we're talking about total distance traveled, which means this is the only one that gets impacted, right?
Okay, if I didn't like calculate it, but I wrote it, do I get anything? I can do all that.
If you can, as long as you leave it to where it could be put into a scientific calculator, yes, you're supposed to get the credit for it.
Okay, so I did like the 12.
I would say if you left it there, yes. That's what I'm scared. I'm always scared. I would leave it there and then come back and do those calculations if I had time. All right, so here, right Riemann, so I've got rectangle, 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 right? So the first one has a width of 12 and a height. I'm using the right Riemann sum, so I'm going to start with 200 plus. The next one has a height of 8 times 240. The next one has a height of 4 times positive 220. And then the last one was huge, and it has a width of, what was it, 16 times 150. So yes, coming over and doing all of those little calculations and computations, by hand was horrible, but I did come up with 7,600. This is just meters because it's total distance traveled.
Okay, so
Well, I got wrong.
well, I just forgot how to do writing.
Okay.
So,
Yeah, I did it right. I just didn't.
All right, so 1 point for your explanation of total distance, 1 point for the right Riemann sum, which would be this, and then 1 point for the answer.
What if I didn't change?
But I would give you credit. I would say that those could be lumped together.
What if I like the right setup, but I didn't change the sum?
Well, because what?
I didn't change the sum.
I would give you the point for the right Riemann sum, but not for the approximation, and that might be why it's split like that. Because they have on their scoring guide, they have 12 times the absolute value of V of 12, plus 8 times the absolute value of V of 20. Just to show you that is the right Riemann sum, but I didn't show you. So I'm saying, right, is okay, yes. Could be considered both. Part C. I liked C and D. I thought they were the easiest. D had a lot of computation. C was 15. 50. 350. 350.
I got 18. I got 18. I did 1 over 2.
C is 15 and D is 350. 15, 350. Okay. No, you got 2 for the answer, yeah. But C is 2 points and D is 3 points. All right, part C. Y'all are getting excited because you're getting some right now. See, I'm like all jacked up. Okay. Part C, Bob is riding his bicycle along the same path between 0 and 10. Bob's velocity is measured by which is meters per minute. Find his acceleration at 5. So this was a straightforward find the derivative because that's the derivative of acceleration of velocity. And then evaluate it at, what did it say? 5. 3 times 25 minus 12 times 5. So 75 minus 60, which is meters per minute squared. Did you find the derivative? You used v prime of t and the answer, so 2 points. Y'all have come so far. Do y'all remember the first ones we did? And y'all were like, I got 0, Miss McGee, on the whole thing. And now y'all are.
How many points was that?
But this was the 2015 exam. I mean, it's not like, I'm not giving you ones that are just practice. I'm actually giving you old exams. That's why I'm hoping you see the pattern. You know what I mean? Like we said, the AP website's a little different. Yay, that's awesome. See? But you're improving, and that's the thing. Are you improving? That's what I want to see is y'all improving. And I know that this is a little less stress than the practice test because you don't have quite the pressure on. So, all right, part D. They're all 9. Everything's always 9. Part D. So based on the model B from part C, find Bob's average velocity. Anytime you see average value of a function, that is 1 over b minus a times the integral from a to b. Average value is 1 over b minus a times the integral. So the average velocity from 0 to 10. Okay, so the integral would be, so you got 1 over 10 from 0 to 10 of, t cubed minus 6t squared plus 300 dt. That's a point. That's a point. Even if you got nothing else. Your second point, average value of a function. That's always average value of a function. Antiderivative. Y'all should have all gotten, if you got 1 point for the integral, you should have 2t. from 0 to 10. There's point number 2. Still haven't evaluated anything. 1 point for
down and try and find 10 4 pounds. 10,000.
So here's what I 1/10. All right, so then you've got 1/4 times, all right, 10 to the 4th. So there's 10 to the 1st, 2nd, 3rd, and 4th. Each power adds a 0. Minus 2 times 10 to the 1st, 2nd, 3rd. 300 times 10, which would just give me one more 0. Of course, minus 0 doesn't impact it. So I got 1/10 times, and I mean, theoretically, you could leave it like that. So they say. I'm telling you what they say. I never trust it, but that's what they say, that you can leave it just like that. This would give me 2,500 minus 2,000 plus 3,000, which 2,500 minus 2,000 is 500, so I got 3,500 over 10, which would be 350 meters per minute. So 1 for the integral, 1 for the antiderivative, and 1 for the answer, for a total of 3.
Dude, I'm just looking.
All right. Out of 27, how did y'all do? Better? Impressive. That's impressive. Y'all scored on that, on those 3, what you scored overall, almost all 6 for some of you last week on the whole practice. So that is awesome. Y'all are doing a lot better. I'm really glad. I am encouraged. I hope you all are encouraged. Stop! Yes, you are. You are.